Okay, so far we have seen some classical crypto system like Cipher, then the substitution cipher, and we have seen the problem with Cipher is basically the key size is very less. Basically, key size is key is coming from Z26. So, size of the key space is basically cardinality of this set. So, this is basically 26, which is broke by the which is not secured because of the less key size, and it is 26 only. So, one can try for 26 possibilities and get the key. So, this was attacked by the brute force method. Then we talk about substitution cipher, which is key is basically the set of all permutations. I mean, key space is set of all permutations over Z26, and that set is basically 26 factorial, which is roughly 2 to the power 88, which is very, I mean, which is very large. So, the exhaustive search or the brute force attack cannot be may not be feasible for this big size. But we have seen, if we are, since we are using the English text for the plain text, then English text is having some certain frequency phenomena of the letter of the alphabet. E is the most frequent letter, then T, then A. So, by that frequency analysis, we have seen an attack on this. So, that is called frequency attack on this substitution cipher. So, it is also broke under this frequency analysis or the frequency attack. So, then these are basically what is called the substitution cipher and this SIP cipher. These are monoalphabetic cipher. Monoalphabetic cipher. So, basically the alphabet is going to a unique alphabet. Okay. So, a alphabet. So, is mapping to a going to a unique alphabet, not a alphabet is going to many alphabets, like the polyalphabetic cipher we have seen, visionary cipher we have seen, the permutation cipher, unique alphabet. And on the other hand, so because of this, the frequency analysis is frequency attack can be mounted, but to avoid this we talk about this what is called polyalphabetic cipher, and there we have seen two ciphers so far. One is visionary cipher and the second one is transportation cipher or permutation cipher. And there frequency analysis may not be so easy because this is a polyalphabetic. So, that means each alphabet is not going to a unique alphabet, it can be going to a different alphabet. We have seen one example where S is going to some different alphabets. So, now today in this lecture we will see another polyalphabetic cipher, which is basically called Playfair cipher. So, this is also an example of polyalphabetic cipher. So, this was invented by Charles. So, Charles Whitson Stone. Okay. So, the idea is to have a matrix which is basically 5 by 5 matrix. So, let us have a 5 by 5 matrix 1 2 3 4 5 1 2 3 4 5. Okay. So, this is a 5 by 5 matrix. So, that means total number of entries are 25. So, this is a 5 cross 5 matrix. Now, this is called key matrix. So, we will put our key in this matrix, okay, and without will not repeat any letter in this matrix. So, how many alphabets are there? We know in English 26 alphabet, but there are only 25 space. So, what we do? So, two alphabets should be kept in a single slot. So, they are basically I and J. So, I and J are kept in this single slot. Okay. So, what we do? How we will make this matrix key matrix? This is key matrix. Okay. Suppose we take a key like Charlie, the inventor name CHARLES. Okay. So, what we do? We first write this name. We just fill this first row, second row like this using the key first. So, we will fill this CHARLES. Okay. So, this we will put in the first we will fill up this matrix. This is row wise we fill, and then we will fill up all the remaining alphabet present in the English alphabet set. So, A is over. So, we do not need to put A. B is not over. So, we will put B. Then C, this is L. C, D is not over. D. Okay. Sorry, this is B. C is over actually. C is over. C we have already seen. So, D is not over. So, D we will put here, and then we will put F over here. E, because E is over. E is already here. So, there will be no repetition. No repetition in the alphabet. Okay. So, that means we just fill up this E, D, F, then G, and then we have to fill I, and I and J will sit together because there is one space is less. So, they have to sacrifice. So, K, M, N, O, P, Q, R. R is already there. So, we will not put R. S is already there. We will not put S again because we are not allowing any repetition. T, U, V, W, X, Y, Z. So, this way we fill the matrix. So, this is called key matrix. Okay. So, it depends on the keyword we fill the matrix. So, if there are repetition in this keyword itself, so we will not take that double, we will take once. Suppose our key is say Lily, Li or something. So, we will just take L then I, that is it, because L already taken. So, this will not take again. Anyway, so suppose this is the key matrix. Now, how we will encrypt a message? So, message is say, so using the keyword we will make this matrix. This is a 5 by 5 matrix. Now, suppose we want to encrypt a message, say message is say the plain text is say this one, meet me at the bridge, meet me at the bridge. Okay. Suppose this is the plain text. So, what we do? We just take this plain text into two letters together, okay. And if it is not if the last we have one letter, we will put a x as a dummy letter. So, if we split this into two letter word. So, if we split it, so M E, then E T, two letter word, then again M E A T T H, then E B, and then E B is over R I, then D G, and last we have a E. So, we have to use a X. So, X we are introducing as a dummy alphabet, this X. Okay. So, this is the letter. So, E X, because last one we do not have anything to split it into two alphabet like this. Okay. So, now how we will encrypt it using this, and if we have a letter like balloon, if we have a letter like balloon, B A L L O N, double L O O N, balloon. So, if you want to split it by this way, so it should be B A L L O O N, but this we do not like. So, this is wrong. So, we do not want any letter, any this 2 bit means 2 letter which is having same alphabet. So, what we do? We will use the dummy letter, dummy alphabet X. So, this will split into like this, B A, then L X. So, this X is the dummy, then L O O N. So, this all are having 2 letters together without any repetition. So, this way we will split. So, basically we have given a plain text, we will split into 2 letters together. Now, we will have we will just how we will encrypt. So, encryption process is like this. So, we will encrypt each of these 2 bit letter alphabet by the following way. So, suppose we have to encrypt E D or E B, sorry. So, this is suppose the plain text bit 2 bit. So, how will encrypt it? So, E B is where? E is where? E is basically E is here, B is also here. So, they are in the same row. So, this rule is for same row. So, 2 letters are at the same row. So, then the corresponding ciphertext block will be S E D, our plain text is E B. So, ciphertext will be S D. So, this will be basically ciphertext is S D. So, basically the next one and next to this, okay, if they are in the same row. Now, if it is like E F, if this is the plain text, then the ciphertext will be what? F. So, it is circularly. So, it is basically S, and for F it will be E. So, S E like this. So, this is the ciphertext corresponding to this plain text. So, this rule is if they are in the same row. Now, suppose they are in the suppose they are in the same column. So, that we have to see. So, suppose same column, let us take an example D T. Is the D T is in the same column? Yeah, D T. So, this means the 2 letters are in the same column, are at the same column. Then what we do? We will take the similarly by in the row what we did, we take the next one. So, if it is dt, so d is here, t is here. So, we will take this m y. So, dt is going to, this is the ciphertext corresponding to dt m y. Okay. And if it is t y, if it is t y, so t y is going to y r. So, circularly. So, for t it is going to next alphabet in that column, because they are in the same column t y. So, t, but for this y it will be r like this. So, this is the ciphertext corresponding to this plain text. Now, the question is, if they are in the they are not in the same row or not in the same column, if they are in the different row and different column. So, let us take an example. Suppose M E. So, if these two letters are not in the same row and same column, sorry. So, suppose M E is the plain text digit, I mean letter. So, M is here, E is here. So, they are not in the same row and same column, they are in different row and different column. So, what we will do? We will take the corresponding, we will take for M will be replaced by the letter which is in that same row and in the same column of the other letter. So, other letter is E, so it is G. So, M will be replaced by G. So, this will be replaced by G and E will be replaced by D. So, G D. Okay. So, this is the plain text 2 bit and this is the corresponding ciphertext 2 bit ciphertext bits. Okay. So, this is the way we will encrypt this this plain text meet me at the bridge. So, if you do it, so what will be the corresponding ciphertext? So, let us just try this. Okay. So, first letter is first 2 bit is M E. So, M is here, E is here. So, it will be basically so replaced by G D. Okay. Then E T, basically E T, where is E T? E is here, T is here. So, E will be replaced by D and T will be replaced by O. So, this is basically D O. Then again M E, then A T. So, A T is basically A is where? A is here, T is here. So, basically A will be replaced by Q and T will be replaced by R. So, Q R. T H, T is where? T is here, H is here. So, T H. So, T will be replaced by P and H will be replaced by R. So, it is basically P R. And E is here, B is here. So, they are in the same column, a same row. So, it will be basically S E B. So, it is basically S D. And R I is basically R. Where is R? R is here, I is here. So, it will be basically M H. Now, D G. So, D is here, G is basically, where is G? Yeah, G is here, D G. So, it will be replaced by D will be replaced by M and G will be replaced by E. So, M E. X is here. So, E will be replaced by V and X will be replaced by B. So, V B. V B. So, this is the plain text, this is the ciphertext G D E O G B Q R E R S D M H M E V B. So, this is the ciphertext corresponding to the plain text, meet me at the bridge. So, this is the encryption, this is encryption. Okay. Now, if we have say G K, suppose our plain text is G K, suppose this is our plain text, then the ciphertext. So, G K is the same row. So, it will be basically either I or J. So, it has two options, it is either I M or J M, because in this place there are two alphabets are sitting together. So, it will be either I M or it will be J M. Okay. So, this is the encryption. Now, how to decrypt it? Say how Bob can decrypt it. So, this is Alice and Bob. So, Alice wants to send this message to Bob using the Playfair cipher. So, they agreed with this key Charles and they form this Alice form this matrix, key matrix, and then Alice wants to send this plain text to Bob that meet me at the bridge. So, this is typically a say secret information Alice want to pass to Bob. So, what Alice will do? Alice will break it into two letters like this and then apply this encryption method, which is given by Charles, and this is the encryption method, and then Alice got this, and this Alice sent to Bob this ciphertext, this G D D O G like this. Now, Bob, upon receiving this ciphertext, Bob has to get back the plain text. So, how Bob will get back the plain text? So, how Bob will decipher it? So, Bob has to apply the, so Bob is getting G D. So, from G D Bob has to get M E. So, G D is where? G D. So, to get M E, so what Bob has to do? So, G D, so G will be replaced by M, D will be replaced by E. So, the same technique Bob has to apply E T. So, E T Bob is getting D O, D O, D and O. So, if Bob will use the same technique, it will be basically D will be replaced by E and O will be replaced by T. So, this decryption is the inverse process of this. So, this we have to keep in mind when we will decrypt it. So, then if we have a same letter like R E, so R I E B E E X E B E B. So, E B was replaced by M H. So, M H. So, E B was replaced by S D. So, when we talk about S D, so S must be, we must get E B, S D. So, the decryption is just the reverse of the encryption. For encryption in Playfair cipher, we take the next alphabet in that row, but for decryption we have to take the previous alphabet in that row, because this S D, when we decrypt it, we should give us E B. So, S D, so this should give us E B. So, this is the inverse way of the encryption. So, this is the Playfair cipher, both the decryption and encryption we have discussed. And so, this is the technique, this is very nice techniques, and this is also called so this is few slide we made. So, this is the Playfair cipher which was invented by Charles, and based on Charles' name we use this key matrix. So, first we write the names without any repetition, then we write then we fill up the remaining alphabet of the English alphabet, removing the repetition. We do not want any repetition in this. So, this is the key matrix, and then we have the following rules like this. So, every plain text we split it into two bit letters, and if the last one is a single bit, we just put a extra bit which is x, extra letter x, and the repetition is not allowed in this diabrit. So, if this balloon, then we just, this we have already discussed, we just put a x there, and this we will break it up, and this is the rule we are using for the encryption, and decryption will be the similar rule. So, EB is replaced by SD depending on where it is. So, if it is in the same row, then it will be the next row, next alphabet in that row, and next alphabet in that the second alphabet in like this. So, NG is replaced by this. So, this is if they are in the same column, and if they are in the not same column and same row, then we know the rule. So, this is the rule, and if we apply this rule, we get this ciphertext corresponding to the meet me at the bridge. And now, the decryption is also the reverse process of it. So, decryption will be the, just we have to whatever we did in the encryption, just reverse way will do, but we have to have the same matrix, same key matrix. So, key is same. So, that key should be shared between Alice and Bob. So, this is the key matrix, Charlie is the key. So, this key matrix should be shared between Alice and Bob, and using this key matrix. So, Bob will just decrypt it using the reverse process of the encryption. So, this is also another example of polyalphabetic cipher. Thank you.